Okay, so today we're going to be talking about solving systems of equations. And so the first thing we probably should talk about is what is a system, okay? And a system of equations, right there, a system of equations is just two or more equations that have the same variables. Okay, so this says what is the solution of the two tables below? Now I know this says equations and these are tables, and you're like, I know they're related, but it's not exactly the same thing. And you're right, but because an equation is used to generate this table in the first place, we know that these are equations just written as in tabular form. This is just a snapshot, if you will, of it. So to get the equation, I could use my methods that we've studied so far to write the equations, but I think a little bit easier would just be to go ahead and graph these points. So let me get a color that you can see there. It's kind of black on black. It's not showing up real well. All right, so we've got 0, 0, 1, 3, 2, 6, 3, 9. Okay, so this is definitely a linear equation. And then we want to look at this other table. So I'm going to change colors so it'll show up a little bit better. 0, 6, 1, 2, 3, 4, 5, 6, 1, 6, 2, 6, 3, 6. Looks like we've got a horizontal line going on there, yeah? Okay, so the solution is where the lines intersect. Okay, it's the point they have in common, and that would be this point right here, which is 2, 6. So 2, 6 is my solution. Let's take a look at another one. What is the solution of the two tables below? Okay, so again, I'm going to graph these points. Four, see that's 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's one equation. And then 0, 5, 1, 2, 3, 4, 5, 1, 3, and 3, negative 1. Okay, and the point of intersection appears to be right there, which was the point 1, 3. So that's my solution. All right, let's look at another example. What is the solution of the two tables? Okay, let's see. Negative 3, 1, 2, 3, 0. 0, 6, 1, 2, 3, 4, 5, 6. 1, 8, 7, 8. Okay, so there's one line. Okay, and then the second is negative 2, positive 2. Negative 1, positive 4. And 2, 1, 2, 10. So it's all the way up here. Well, if I connect them, I'm going over the exact same line. Okay? So what we say here is because all of these points are solutions, that there are infinitely many solutions. Okay. Let's take a look at one more example. Alright, Gia made the table below. This equation, this equation. Okay, so she just put her two tables together just because she used the same x's. And so what we can do here is we'll just look at these first two numbers and graph them, and then we'll do the first and the last for the second equation, because the y's are the changing, x is staying the same for all of them. So it's going to be negative 3, 1, 2, 3, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 1, 2, negative 5. 1, 2, 3, 4, 5. Negative 1, negative 2. 0, 1, 1, 4, 2, 7, and 3, 10. So there's my first line. Okay, second line, negative 3, 0. 1, 2, 3, 0. Negative 2, negative 1. Negative 2, negative 1. Negative 1, negative 2. Zero, negative 3. 1, negative 4. 2, negative 5. And finally 3, negative 6. So it appears that right here is our point of intersection, which is negative 1, negative 2. It is also on the table right here, negative 1, negative 2. See how the two y columns are the same? All right. Now you get busy on solving systems of equations 1.